Hello, ladies and gentlemen. Today we're going to take another look at functions, but we're going to spend our time evaluating functions and understanding their graphs. So our learning targets today are that we can read functions written in function notation, that we can evaluate them accurately, so you may want a calculator, and that we can determine if a relation or a graph represents a function. So we can look at a graph now and say, yep, that's a function, or no, it's not going to be. So back in your Algebra 1 experience, we wrote our function rules most likely as y equals 3x plus 4. You learned y equals mx plus b, okay? You always had an x and a y there. Sometimes you saw functions written in function notation. Okay, that is just where the y is replaced with a name for the function. So please make sure you write this whole slide into your notes, okay? Because it's very important that you know what this notation is telling you to do or what it means. So the only thing that's different between what you know from Algebra 1 and what you will see now is that that y has been replaced with a name for the function. So notice that there's an f, then some parentheses, then an x. Okay, that f in front is in fact his name. So we're going to name the function with a letter. F is the name of the function. Sometimes it's G, sometimes it's H, okay? But there's a name there. This is function f, okay? This is f, and then the x after it does not mean f is multiplied by x. No, no, no. It means x is the input value. So we have the function named f that has an x in it. Okay, function f with x in it equals, and then there's the rule, 3x plus 4. So the function with x in it equals 3x plus 4. So that rule is what we would use then to plug x values into to find corresponding y's. So the whole thing on this side, the f with the x after it, that has replaced the y that we're familiar with. Okay, that used to be y. It still means y, except we're in higher level math now, and so we'll say that this means the value of function f at x. So if I were to plug in an x value, this would be its value at that x value. Now that's a lot to say each and every time, so what we read it as is we'll say it's f of x. So when you hear me say f of x, I'm just referring to this function right here, and this is the equation that we're talking about. Now when we evaluate function rules, guys, we're going to basically substitute and think back to what you learned in Algebra 1. So here we have an example here. We have two functions. We have f of x, okay, or the function f at x. And then on the b side over here, we have g of x, or the function g at x. It has x in it, essentially. Now, both of these functions have two different rules, right? But we're supposed to evaluate each one where x is negative 2. So that means we're going to go ahead and plug in a negative 2 where the x is, okay? Now last year you may have sort of ignored this part right here. You may have ignored that part. You thought about it as a y, and you just focused on plugging in the x over here. But remember, this means plug it in where x is negative 2 every time you see an x. So what I would write then is I would say f parentheses negative 2 equals negative 3, and then another set of parentheses, negative 2. So everywhere there was an x, I'm plugging in a negative 2, equals 7. And now when I go ahead and calculate this, remember that this side over here is like a label. It's a name. This is saying the value of function f at negative 2. This is not something I have to calculate. On the other side is where my calculations go. So negative 3 times negative 2, because we do PEMDAS, right? We remember our PEMDAS, start with parentheses, exponents, multiplying and dividing, and adding and subtracting. These two numbers are supposed to be multiplied, so it becomes positive 6 plus 7. And if I continue calculating that, I get 13. So when I finish this, let's try that again. When I finish this, I'd say the value of function f at negative 2 is 13. That's how I would leave it. We're not solving for f. F is not something we're trying to say f equals something. F is the name of the function. Okay, let's try another one. Let's do the g this time, the g function over here. So we're going to do g of x. So now we're going to plug in -2 where the x is. Sorry, I'm having technical difficulties here. -2 where the x is. So everywhere there's an x, there's an x in two places on this side over here, we're going to replace it with a -2. Now remember, I'm only going to calculate on the right-hand side here because this left-hand side is his name. It's describing what's happening. We're finding the value of g at -2. And -2 squared. Now be careful, that's -2 times -2. That is +4. And next, I would not add yet, guys. I would just do multiplication. Now we would take 2 times -2, that's -4. And now I would just drop down that subtract 10. So remember your order of operations, start with any parentheses, do your exponents first, that's why I did this guy first, then do any multiplying or dividing, and last we will do adding or subtracting. So 4 subtract 4 is 0, minus 10 more makes -10. So the value of g at -2, or g of -2, equals -10. That's my final answer. Now there are other ways this can be written. Notice that you don't have to say what x equals. So let's continue doing this idea. There are two more, again, my g examples, my f and my g. Now we're going to plug in two different values. Notice this time it doesn't tell me x equals -4. It says find f of -4. That means use the f equation and plug -4 into it. So I'll go ahead and do that. Here's the f equation, or the f function here. We'll go ahead and plug -4 in everywhere we see an x. And now using my order of operations, -3 times -4 is 12, plus 7 makes 19. So the f of -4, or the value of function f at -4, is 19. Let's go ahead and do this next one on the other side over here. We're going to find g of -1. That means in the g function here, we're going to plug -1 in everywhere we see an x. So g, -1, finish up my g here, and then -1 squared plus 2 -1. You'll notice every time I plug in a number, I put parentheses around it, just to help me stay focused here and know what my value is that I was plugging in. So let's go ahead and start calculating. -1 squared is what I do first because it's PEMDAS. So parentheses, then exponents. Exponents comes before anything else. So we'll go ahead and -1 squared is -1 times -1. That would be +1. After that, I would look for any multiplication or division, and I have that here. So I'll go ahead and calculate 2 times -1 is -2. And then I'll drop down my -10. And now I'm just down to subtraction here, guys. So 1 minus 2 is -1. Minus 10 more makes -11. So the value of g at -1, or g of -1, equals -11. So we've been evaluating functions. Now let's take a look at graphs of functions. Let's consider that we gathered information about people and their heights. And we could make two graphs from this, guys. We could put people's names on the bottom right and then how tall they are. Joe is 6 feet, so on. Or we could organize them a little differently. We could put the heights on the bottom and we could put their names up there like that. Now, depending on which way we basically label the graphs, is basically whether it's a function or not, okay? So if we take a look at the first one with the names on the bottom, you can see that every x value here has one y value. So remembering what we learned about functions, this is a function. Every x has one y. Now over here, this x value has two different y values. That means he is not a function. So the x value of 5 has two different y values. That means that he's not a function at all. So notice how those 2 points lined up. It was the same information, right? It's the same data. It's just we labeled the graph differently. We turned the graph. So this idea that when you're looking at graphs, we look for something maybe different than you would on a mapping diagram. On a graph, we're looking for this situation where dots would be lined up vertically. So that means in order to be a function, it has to pass what's called a vertical line test. Write this part in your notes. A vertical line test is a relation, is a function if a vertical line drawn through its graph passes through only one point. That is, you're very careful to make sure that there are no two dots or two spots that would line up vertically. So that vertical line test is what I use when I already have a graph made. So when all the points have been plotted and I don't want to make a mapping diagram of it, I would go ahead and just use the vertical line test. Now, an easy way to get a vertical line is to actually take your pencil and hold it vertically, that's up and down, and move it from left to right across your graph and see if it hits in more than one point. So we'll take a look at what that looks like. So vertical line test, remember this is the one we were just doing. Now if you used your pencil, you'd put your pencil up like this and you drag him over and you'd say, am I hitting? Oop, this is bad. I hit two dots at once or two spots on my graph at once. So that means that it is not a function. That's what we would be looking for. So let's take a look at a few that aren't just, random points. This is a line that's been graphed. If I take my pencil and I were to drag it, it only hits one spot on that line at a time. It doesn't double up at any time. So that means that this is a function. Lines are functions, okay? Linear functions. What about this one? If I were to drag my pencil across this one, what do you think? Would it be a function? Well, at some point when I go across, I'm going to hit the graph one time, but at this spot, I'm hitting it in two places as it passes across, okay, as it hits that curve. That means that he is not a function. So I don't have to look at each set of individual points in a mapping diagram to figure that out. All right, thank you very much, ladies and gentlemen, for taking lovely notes, and I'll see ya.